Welcome to the wild world of statistics. It's not all boring charts and graphs, you know. Today, we're talking about something exciting: variability. What's that, you ask? Well, imagine you're looking at a bunch of numbers. Variability tells you how spread out those numbers are. Think of it like this. You have two bags of candy. One bag has all the same kind of candy, boring. The other bag has a mix of everything. That's variability. In statistics, we love a good mix. It makes the data more interesting and tells us a lot more about what's going on. In this essay, we're going to explore the different ways we can measure this delicious variability. Get ready to dive into the world of ranges, quartiles, and deviations. Let's start with the simplest measure of variability, the range. Imagine you're stretching a giant rubber band. The range is like measuring how far that rubber band can stretch. To calculate the range, you take the biggest number in your data set and subtract the smallest number. Boom! You've got the range. For example, let's say you're looking at the ages of people in a room. The youngest person is 10 and the oldest is 60. The range would be 50. 60 minus 10 equals 50. The range is a good starting point, but it's a bit basic. It doesn't tell you anything about how the numbers are spread out in between the highest and lowest values. For that, we need to dig a little deeper. Next up is the interquartile range, or IQR for short. Don't let the fancy name scare you. It's actually pretty straightforward. Remember those median lines they draw on roads? The IQR is like finding the median of the data, then finding the median of the top and bottom halves. It's like finding the median twice. To calculate the IQR, you first need to find the median of your data set. Then, you find the median of the bottom half of the data. This is called the first quartile, or Q1. Do the same for the top half of the data. This is called the third quartile, or Q3. Finally, subtract Q1 from Q3, and you've got your IQR. The IQR is a bit more nuanced than the range because it focuses on the middle 50% of the data. This means it's less affected by extreme values or outliers. Section 4, variance. Measuring the square of the difference. Now things are getting interesting. Variance is a measure of how much the data points in a set differ from the average or mean of that set. It's like looking at how far each number is from the center of the group. To calculate variance, we first find the difference between each data point and the mean. Then, we square each of those differences. Why square them? Because it amplifies the effect of larger differences, giving us a better sense of how spread out the data is. Finally, we average all those squared differences together. Variance is a powerful tool because it takes into account every single data point. However, it's important to remember that variance is expressed in squared units. This can make it a bit tricky to interpret in the context of the original data. That's where standard deviation comes in. Section 5. Standard deviation. Back to the roots. Standard deviation is simply the square root of the variance. By taking the square root, we bring the measure back to the original units of the data, making it much easier to understand. Think of it as undoing the squaring we did earlier. A small standard deviation means the data points are clustered close to the mean. A large standard deviation means they are more spread out. It's like measuring the average distance each data point is from the center of the group. Standard deviation is one of the most commonly used measures of variability because it's both powerful and easy to interpret. Section 6. Why variability matters. So, why do we care so much about variability? What does it really tell us? Well, understanding variability helps us make sense of the world around us. It helps us see patterns in data, make predictions, and understand the likelihood of certain events occurring. For example, let's say you're a teacher looking at test scores. If the variability is low, it means your students are all performing at a similar level. But if the variability is high, it means there's a wider range of abilities in your classroom. This information can help you tailor your teaching methods to better meet the needs of all your students. Variability is everywhere. It's in the stock market, the weather, and even the way we talk. By understanding how to measure and interpret variability, we can gain a deeper understanding of the world and make more informed decisions. So, embrace the spread and let the power of variability guide you.